So two things are happening here. We have our hoop that's rotating, and it's also moving, right? So not only does it spin, but as it's spinning, it moves along this surface. So it has rotational motion, and this is called translational motion. It's another way to say linear, okay? Translational. Okay? So we're going to figure out the kinetic energy of this rolling object by adding the rotational kinetic energy to the translational kinetic energy. And that will give me total kinetic energy. So we're going to start with a hoop, but then we'll throw in like disks and spheres. Okay. Rotational kinetic energy is 1/2 times the rotational analog for mass, which is I, times the rotational analog for velocity squared. 1/2 I omega squared. And regular old kinetic translational kinetic energy, words come out of mouth. There we go. That equals total. Now we can simplify this a bit and put it all in linear terms by substituting the formulas for these two variables. So I for a hoop is just mr squared. And then look on the board and tell me what the linear version of omega W, what can we substitute for the omega? It's in purple. V over R, thank you. V, and I'm just going to, everything is squared here, right? V squared over R squared, because that is squared. I'm going to add that to 1/2 mv squared. Okay. Anything cancel there? Yep. Radius go bye-bye. So we end up with 1/2 mv squared plus 1/2 mv squared. Oh my God! Are those like terms? You betcha. What do you get? How do you simplify this? Just 1 mv squared, right? These are, so yay. mv squared is the total kinetic energy for a hoop. So just for a hoop. And the multiplier here is just 1, right? If I do this exact same thing, and I'm not going to have you require you to derive this for all the shapes that are possible out there, but what's the only thing that's going to change? So if I do this, but just now, a disc, a sphere, a cylinder, a rod spinning on its end, whatever it is, what's the only thing that changes? The shape constant. Thank you, Drew. The shape constant. So that multiplier is going to be different. Look up there, orange. Do you see those 3 formulas? Hoop, disc, and sphere. I promise I won't give you any other shapes. So notice the only thing that changes is that fraction. So it's 1 for a hoop, 3/4 for a disc, 7/10 for a sphere. And that is because this x value, when you like do all the fraction-y stuff, that's what ends up changing that number right there. Okay? I mean, I could go through and derive all of it, but I would not require you to. Don't make me do it. Deal? Trust me?